Hi guys, this is Jagan Babu, Assistant Professor, Department of EC, RMD Engineering College, handling the DSP subject. So let me have some video lecture based on the topic multi-rate signal processing. Subject code is 22EC601 Digital Signal Processing. Unit number 5 Multi-rate Signal Processing. Topic Interpolation and topic Decimation. First topic interpolation. Last video we discussed the type of the multi-rate DSP. Interpolation is one of the type which is also called as upsampling. Similarly, decimation, other name of decimation is called as downsampling. Let me have a brief discussion now. First topic is interpolation, which also called as upsampling, which is called as increases by the factor. Next topic is called as decimation, which is called as downsampling, which is called as decreasing the factor. So multi-rate signal processing using these two types. Why? Multi-rate signal processing is a type of a system that produces multiple sampling rates conversions. When you go for multiple rate sample conversions, that is nothing but analog to digital A by D and digital to analog D by A conversion process. That conversion process is called as the sampling rate conversion, which will have a factor of increases or decreases. When it comes to the decreases, it is known as a decimation. When it comes to the increases, it is called as interpolation. Interpolation is also called as upsampling. Decimation is also called as a downsampling. First topic is interpolation. Definition: upsampling by the factor L increases the sampling rate. So I am giving a upsampling 2 by 2, 2 by 2, 2 by 2. I am taking a 2 cross 2 matrix that is called as capital L, which is increased by the 2. Insert L minus 1 zeros between the samples. So total L should be reduced by 1. Low pass filter to remove the spectral images. It's very important. We use default low pass filter to all the cases. Then need to go for the high pass filter. What is the frequency effect of the interpolation? Spectrum replicates L times low pass filter smooths. That's the frequency effect. It keep on replicates. What is capital L? Which is nothing but the upsampling factor when you get the low pass filter to be smoothens. Interpolated structure. That means that x of n given with increasing of the L factor with the help of the low pass filter, I'll get the output y of n. So the conclusion of the interpolation means increasing factor. Interpolation means upsampling. So upsampling and increasing to be done based off some factor. That factor is called as capital L. Once you calculated the capital L, you need to insert L minus 1 zeros between the samples. Let you have L is equal to 10. Now how many zeros I have to insert? L minus 1, that is called 10 minus 1, 9 zeros to be inserted between the samples. Then that is called as an insertion of the L minus 1 zeros. Now we have to smooth our curve with help of the filter that I taken the low pass filter to remove the spectral images, to remove the noises. Now it smooths with help of the low pass filter to get the spectrum with the factor of the L times. Now the structure will be x of n, which is equal to increasing L with help of the low pass filter with y of n. Now go to the next topic called decimation, downsampling. Downsampling by the factor m reduces the sampling rate. There it increases, it reduces. There I taken the factor L, here I am taking the factor m. What is the frequency effect here? It expands, causing the aliasing. So aliasing the filter and anti-aliasing filter is very important. Here the frequency effect is called as aliasing. When two signals are merged, aliasing signal will happen. There we need to introduce a Nyquist concept. The decimator structure. X of n give us to low pass filter, decreases m, you get the output y of n. There increasing L with low pass filter, you are decreasing m with low pass filter. Hope you understand both concepts, interpolation, decimation, right? Thank you guys.